Welcome to the Water Engineering channel. In this video, I'm going to explain you what is a progressive cavity pump. You will also learn the classification of pumps and all the informations about the progressive cavity pump, like how it works and what are the advantages and disadvantages of this pump. So watch the video to get the complete understanding of this topic, and don't forget to subscribe because that way you will get the notification of my future videos. You can subscribe right now just by clicking the subscribe button on the right hand side of your screen. So let's start this video with the classification of pumps. Pumps are employed in a variety of commercial and domestic settings. Pumping equipment comes in a wide variety of types, sizes, and construction materials. Although liquid is typically the pumped medium, many designs can also handle solids and suspension, entrained or dissolved gas, paper pulp, mud, slurries, tars, and other unusual materials that, at least on the surface, do not resemble liquids. Based on how they transfer energy to the pumped medium, pumps can be classified as either dynamic or positive displacement. In dynamic displacement, the fluid is moved from the pump suction to the discharge by the centrifugal force of a revolving component known as an impeller. On the other hand, positive displacement moves the fluid from one place to another by using the reciprocating motion of one or more pistons, or the squeezing motion of meshing gears, lobes, or other moving components. Reciprocal and rotary pumps are the two main categories under which positive displacement pumps fall. For reciprocating pumps, a plunger, piston, or diaphragm moves back and forth as a result of the pump's reciprocating action, causing liquid to flow into and out of the pump. For rotary pumps, a system of gears and lobes draw liquid into the suction nozzle. You can see the animation of the liquid being forced out of the discharge nozzle. Screw, vane, and progressive cavity rotary pump types are additional ones in use. We'll talk about the progressive cavity pump in this video. Dr. Rene Moinot developed the progressive cavity pump after World War I as a supercharger for an aviation engine. This pump is not typically utilized or thought of as the same as other rotary positive displacement pumps, due to its multi-phase and high suction capabilities and capacity to convey significant amounts of air, vapor, or gas in a fluid, which may also contain particles. A rotary pump and a piston pump were combined to create the progressive cavity pump. It symbolizes the fusion of the unique benefits of the two different pump construction styles. Progressive cavity pumps are sometimes referred to as cavity pumps, prog cavity pumps, and PC pumps. The wastewater treatment plant is where progressive cavity pumps are most frequently utilized for the transfer of thickened and treated sludge and the dosing of polymers. The pump is employed in the transfer of cuttings, drilling mud transfer and recovery, separator feed, and crude oil. Progressive cavity pumps can be made to minimize the danger of contamination in food and beverage applications. The pump is also employed in the pumping of sewage, slurry, and sludge. The transfer of pulp, recycled paper, and filler takes place using a pump in the paper and pulp industry. To understand how the pump works, we must start by knowing the pump parts. The pump is made of several different parts based on the type and the supplier of the pump. Here, I have covered the most important parts in a standard progressive cavity pump. You can see the different parts of the pump. I have framed the main components here. So let's start with the first part. The stator of the pump is constructed in a single block and features a steel outer shell with an inside rubber double helix profile. Neutral butadiene rubber, ethylene propylene diene monomer rubber, fluorocarbon, and polytetrafluoroethylene are the main elastomer types used in the manufacture of stator materials. These materials are selected based on the abrasiveness of the media, the chemical aggression of the fluids, and the range of working temperatures. The second component is the rotor. They are manufactured of annealed alloy carbon steel with a 0.3 to 0.4 mm layer of hard chrome coated on the outside, depending on the working environment. Rotors are made of stainless steel and also have a strong chrome outside coating for conditions that are extremely corrosive and aggressive. The shaft sealing is the third component. It was chosen to survive working circumstances and is one of the mechanical seal or gland packing type, which is constantly lubricated by the circulated fluid. The drive gear is the final component. It can be any major manufacturer's geared motor, variable speed drive, or hydraulic motor that is directly flanged to the pump without the need for additional couplings or guards. Pumps come with a choice of accessories to ensure compatibility with your process. It is capable of having a dry run sensor, which utilizes a PT100 temperature probe to detect when the stator temperature exceeds a predetermined degree and shuts off the motor to prevent the dry running of stators. Additionally, a protection against excess or underpressure can be added to the pump. When the pressure falls below or rises above the preset amount, a diaphragm pressure gauge for highly viscous media changes. A progressive cavity pump is a fluid-producing device, much like other positive displacement pumps are. Let's look at how it functions. The fluid is drawn by the pump through the suction intake and moved into an extended casing. Helical rotor and stator are contained inside the housing. Small cavities form as a result of the rotor's contact and the stator surface as it rotates. The fluid then progresses through these rows of cavities before being discharged through an outlet. Regardless of the inlet pressure, the pump maintains a consistent speed when moving the displaced fluid. The geometric profile of progressive cavity pump stators is crucial to take into account. Different flow rate and pressure stability are accomplished by modifying the design. So choose the proper stator based on the characteristics of the fluid. There are typically 4 different stator geometry technologies available in the market. Wide fluid handling characteristics make these pumps one of the most adaptable ones available. They can handle viscous liquids, big particles, abrasive materials, fibrous solids, and gas slugs without trouble. There are no comparable pumping technologies since this design has unparalleled viscosity, handling viscosities from 1 centistokes to 1 million. Also, it has strong suction capabilities ranging up to 8 million with a commensurate low NPSH, thanks to the strict tolerances used in its manufacturing. As flow is inversely related to pump speed and has a cavity design, it allows relatively predictable flows, making it suitable for use in metering and dosing applications. The fact that the pump may be operated in either direction with the suction acting as the discharge and vice versa is another benefit. Depending on the installation, the pump may also be operated vertically or horizontally. Now for the drawbacks. The main cause of these pumps failing is by far running the pump dry. A fluid coating is therefore needed to lubricate the stator and rotor. Low speed also necessitates the use of gear reducers and/or VFDs, which raises the installation cost. Additionally, low viscosity fluids have a tendency to slip beyond the rotor's fit with the stator, making the pump less effective. Also, there is a pump speed over which the fluid won't flow into the pump quickly enough for highly viscous fluids. The pump's volumetric efficiency is compromised when this happens. The speed restrictions for a specific fluid and viscosity can be determined with the help of the pump's manufacturer. In a water treatment plant, these pumps are used for metering and dosing polymer. Here you can see the installation of the pump vertically or horizontally, depending on available space. Here is another picture of a progressive pump feeded by a decanter centrifuge. As you can see, progressive cavity pumps are an attractive option for a variety of reasons. Whether you are pumping food and drink products, viscous chemicals, or in need of a downhole directional drilling mud motor, this style of pump offers incredible efficiency and reliability. If you want to learn more about water treatment and wastewater treatment equipment, subscribe to my channel and hit the bell icon so you can get the notification of a new video. Please like and share this video with your friends. Goodbye and take care.